Use a tree diagram to write down the chain rule for dw dt if w is a function of x, y, and z, such that x, y, and z are functions of a parameter t. So in order to come up with the chain rule for dw dt, we need to define this function first. So what exactly are we given? So rereading this question a little bit more closely, we see that w is a function of x, y, and z, such that x, y, and z are functions of a parameter t. So we have a function w that's defined by three independent variables, x, y, and z. Now this is such that each one of these independent variables is parameterized by t. So this is such that we can write x of t, y of t, z of t for some arbitrary parameter t, so our scalar value. So let's create the tree. So we know we're starting with a function w, and now w is a function of x, y, and z. Now x, y, and z are functions of t. So to create this branch, or this tree, we need to define our branches. So to do that, we want to connect each variable with a line, where the line represents a partial derivative. So starting from w, the line connecting w to x is the partial derivative of w with respect to x. The line connecting x to t is the derivative of x with respect to t. The line connecting w to y is the partial derivative of w with respect to y, and the line connecting y to t is the derivative of the derivative of y with respect to t. And last but not least, the line connecting w to z is the partial derivative of w with respect to z, and the line connecting z to t is the derivative of z with respect to the parameter t. Now, in order to write down the chain rule for dw dt, we now need to multiply the partial derivatives along each branch and then take their sum. So we have, starting on the left-hand side, we have the partial derivative of w with respect to x multiplied by the derivative of x with respect to t. So our first product is the partial derivative of w with respect to x multiplied by the derivative of x with respect to t. Moving along the middle branch, we have the partial derivative of w with respect to y multiplied by the derivative of y with respect to the arbitrary parameter t. And last but not least, moving along the branch furthest to the right, we have the partial derivative of w with respect to z multiplied by the derivative of z with respect to the parameter t. So our beautiful final answer here, the derivative of w with respect to t, our arbitrary parameter, is equal to the sum of the products along each branch. So we have done it. This is our beautiful final answer for the derivative of the function w with respect to the arbitrary parameter t.